All right, math fans, back at her. Now, we're going to be solving right triangles. Now, really, solving a right triangle is, we have this whole blurb of how to do it, but really, you just do it. So when we solve a right triangle, what it really means is solve every piece of information about it. And just so you know, there are 3 angles in a triangle and 3 sides. So that's what you need to find out. The good news is, since it's a right triangle, you know that one angle for sure is 90 degrees. So let's just jump straight to this, and we're going to solve this triangle. Now, how am I going to do this? Well, keep in mind the baggage that we're bringing with us. We know the Pythagorean theorem, which says c squared is equal to a squared plus b squared, that the hypotenuse squared is the sum of the square of the other 2 sides. And that's going to be really helpful. And as soon as I write that down, you're probably figuring, I can figure out the hypotenuse, which is great. Another thing that I can do is I know the trigonometric ratios, which is sine, cosine, and tangent. So that's all good. Let's just start this. If I'm solving this triangle and I'm solving all missing sides and angles, I have 2 pieces of information. Yet these 2 pieces or 3 pieces of information, if you include the right angle, I need to find the hypotenuse side. So I'm going to label this with lowercase c and simply say c squared is equal to a squared plus b squared. And if I'm labeling my triangle, this is side A and this is side B. So really, c squared is equal to 9 squared plus 10 squared. C squared is equal to 81 plus 100. C squared is equal to 181. Therefore, c is the square root of 181, which you and I both know that that is likely irrational. But regardless, I am going to punch this into my calculator. I get c is equal to 13.454. Now it's not degrees because it's just a measurement of the side. So does that seem reasonable? For sure it seems reasonable because it's the hypotenuse and it's the largest side. So there's one piece of information. I'm going to put that in a box so it sort of smacks you when you look at the question. Now, I have 2 angles to figure out, A and B. I could call one theta, if you guys want. Theta. Now, which one is theta? I don't know. Pick one. And by the way, I have 3 sides. I have 10, 9, and C, which is approximately 13.454. We would like to maybe use A and B because it'll provide the most accurate results. If you're going to use C, which we figured out to be 13.454 approximately, I would encourage you to use all of the decimal places that are found in your calculator. But probably just stick away from this number in all future calculations. Just in case there's an error, you're going to carry that error through. Regardless, if that's theta, this is going to be adjacent, and this is going to be the side opposite. So I know that tan theta is equal to opposite over adjacent. Tan theta is going to be equal to 10 over 9. So theta is going to be the inverse tan of 10 over 9. And what I get is theta is equal to 48.013 degrees. So I'm going to keep that to 3 decimal places. So I have theta is equal to that. And really, when I'm talking about theta, I'm talking about angle B. So now that I have angle B, how do I get my last piece of information? And my last piece of information would be A. So I'm going to switch colors for A. How do I find angle A? Well, angle A is just simply 180 degrees minus 90 degrees minus my theta. And my angle A is going to be 41.987 degrees. So what is the connection between angle A and B? Angle A and B are what are known as complementary angles, that the sum of two of them is 90 degrees.